This video shows how to install the vers.by probe and adapter on a Pocket NC 5-axis mill and how to perform basic operations. This is a non-Pocket NC approved modification, but works for me. These instructions can be found in written form at the GitHub link in the description below. Let's get started. To begin with, attach the adapter housing to the A-axis stepper using a cable tie. The cable tie should be pulled very tight, as it will help keep the enclosure sealed from chips. Disconnect the RJ45 cable from the A-axis carriage and connect it to the bottom RJ45 port on the adapter. The 1-foot-long Ethernet cable should then be connected from the A-axis carriage to the top port on the adapter. Note the layout of which cables are in front of each other. To insert the probe, the X-axis must be out of the home position. Note the machine cannot be homed while the probe is inserted, or it will crash. Remove the screw cap from the adapter enclosure. Attach the provided probe cable to the USB port. Note, this is not actual USB, but this is the cable that the vers.by ships with. Attach the magnetic coupled end of the cable to the probe. When the machine is powered and the probe is activated, you will be able to see the probe light up red. Upon first installation, use the recessed M2 adjustment screws to true up the tip, first by eye, and then with a dial indicator if desired. When removing the probe, be sure to reinstall the USB cap, otherwise chips may fall into the connector. If you want to use the ID and OD scripts from the JPeeper PNC under probe repository, you need to copy the scripts to your Pocket NC and modify some configuration. I'll show the process from Windows. If you're working on Linux, you can hopefully figure out the necessary rsync commands yourself. First, we'll download a zip file containing the JPeeper PNC probe repository from GitHub. Then we can extract the subroutines folder somewhere to your local hard drive. Next, we'll use WinSCP to connect to the Pocket NC. The IP address will be whatever you normally use, and the default user and password is Pocket NC and Pocket NC. Navigate to where you extracted the files and copy the subroutines directory to home Pocket NC subroutines on the Pocket NC. Now we can update the machine configuration to find those files. For kinetic control, use the Config tab, then Server, then INA Overlay, and then Edit Overlay. If RS-274NGC is not in the group list, add it with the plus button. Then make sure the subroutine under path, all capitals, key exists and is set to the value shown and written in the README. If you had to change anything in the INI overlay, click Reboot Machine. G38.2 can be used for simple cases. Here I'll probe the edge of the B table threads. I like to use G21 to operate in metric units, and then I'll use G0A90 to get the table into position, then X0Y0 to move the probe to the center. Now I'll use the manual tab motions to get the stylus near the surface to be probed. I'll specify a feed rate, then list G38.2 with the desired X final position. Once the probe is completed, you can read the value off the DRO. To use the ID or OD scripts, you first manually position the stylus with the Z-axis to the depth you want to probe at, and along either the x equals 0 or y equals 0 axis, a few millimeters away from the surface. The script will probe the same distance from G54 center for each of the other cardinal directions, so you need to leave a little margin. Once you've positioned it, select the Production tab, then upload the NC files from the GitHub repository. Then select the Probe Center ID script. Press Cycle Start, and it will work through the probing cycle. When that is done, it gives you a warning with the diameter and center position. It also sets your G54 offset and positions the probe immediately over the center of the feature. As mentioned before, you can find these instructions written down in the GitHub repository, linked in the description below. Happy machining!